Okay, so there's your warm up. So what I'd like for you to do is just take about 5 minutes, pause the video, so you can see those 6 questions, maybe take 6 minutes, pause the video, and see if you can come up with those in factored form. So you've got to be able to factor those in order to do today's lesson. So the first thing we want to do is just make sure that those are solved in factored form. So pause the video. Again, pause the video to make sure that these are in factored form. Remember, when they don't have a 1 in front, that's when you have to multiply the first term times the last term. So we have factors of -15 that are going to add up to be -2. So what that tells me is I'm going to have a -5 and a +3. So I've got 3p, just going to do this one to refresh your memory, minus 5p, 3p squared minus 5p plus 3p minus 5. And then we would group it up. Group that factoring spirit up. Group it up. Woo! So we would factor out the p, and that's going to give us 3p, because that's what they have in common. So we take the 3p out, we are left with 3p minus 5. And we look at the next set of parentheses, and the only thing they have in common is 1, so we factor out the 1. And that leaves us with 3p minus 5. And so they both have 3p minus 5. And when we take that out, we're left with p plus 1. So that's just your refresher. So that's how that would factor. Same thing for the next one. We're looking for factors of -18 that add up to be 3. So that would be 6 and -3. Then we're looking for factors of 3 times 4 is 12. That would add up to be -8, -2, and -6. For factors of 60, it would add up to be 19. That would be 15 and 4. Factors of 10 that add up to be 11 would be 10 and 1. And factors of 4 that would add up to be 5 would be 4 and 1. Okay, so if you haven't taken the quiz from last chapter, which was quiz 12, you need to email me about that, because you should have had it done before today. Now, if you were absent and something like that happened, email me, but otherwise that quiz is over. I'll be updating grades today and tomorrow, I hope. But what we're looking at today is we're starting our next chapter, which is quadratic equations. And what we're going to be doing today is solving the quadratic equations using the zero product theorem in order to solve quadratics. So the zero product theorem is a result of factoring. So we will have to factor our equations, factor our quadratic portions, and then apply the zero product property. The zero product property says that if two things multiply to equal 0, at least one of them has to be 0. Now, a quadratic equation is an equation of the form ax squared plus bx plus c, and that should say equals 0. So let me go ahead and put that in there. So it should be of that form. Okay, so it has to equal 0. If it doesn't equal 0, then we have to do some manipulation in order to get it equal to 0. The solutions to quadratic can be found 3 ways. Probably more ways if you include all the ways that you can cheat on your phone. We will investigate the following ways. One way is factoring. That's the first way we're going to look at. The second way is the quadratic formula. We'll look at that next class. And then the third way would be to analyze the graph, so we can solve it by graphing. When we solve by factoring, we use the zero factor theorem or the zero product theorem. It states that if A times B equals 0, then either A equals 0 or B equals 0. So the only way something can equal 0 is if one or both of the factors equal 0. So we set the quadratic equal to 0 by getting all of the terms to one side of the equation. That's the first step. It has to be equal to 0. It has to be in descending order. We're going to have our x squared terms first, then our linear terms, then our quadratic terms, or excuse me, then our constant terms. And then factor the polynomial completely. So you're going to factor it till you simply can't factor anymore. Okay? And then we set each factor equal to 0. And solve the little equation. So, first step, set the equation equal to 0. So we're going to add 6 to both sides. Make sure it's in descending order. So we've got 3x squared plus 9x equals plus 6 equals 0. Okay? Beautiful. It's in descending order, and we're going to factor completely. First thing we check for when factoring is a GCF. This has a GCF of 3. So we take the 3 out. That leaves us with x squared plus 3x plus 2. Now, when you look at that, okay, now I'm looking for factors of 2 that add up to be 3. Now, I don't have to worry about doing the grouping part because my coefficient here is 1. So when I factor this, factors of 2 that add up to be 3 are 2 and 1. So now I'm going to have x plus 1 and x plus 2. And I still have my 3 along for the ride. Now, I can't factor that anymore. Everything is linear. So now we're going to use the zero factor or the zero product property in order to set these terms equal to 0 to find our solutions. So we have 3 equals 0. 3 doesn't equal 0. That makes no sense. X plus 1 equals 0. X plus 1 equals 0. We would subtract 1 from both sides. So x would equal negative 1. And then x plus 2 equals 0. And we could subtract 2 from both sides, and x would equal negative 2. And these would be our solutions. Okay, now, if we graphed this equation, three x squared, so y equals 3x squared plus 9x plus 6. What you see is crosses the x-axis at negative 2 and negative 1, and those were our solutions. That is not a coincidence. That's how it's always going to work. Okay? Boom. So let's solve this one by factoring. First step, is it equal to 0? It is. Second step, is it in descending order? It is. Third step, factor the polynomial completely. Is there a GCF here? There is. Factor out the x, and we're going to be left with x plus 9 and that equals 0. Can't factor any further because this is to the first power, this is to the first power. So now we use the zero factor theorem or the zero product property to set our properties factors equal to 0. And we find x equals 0 and x plus 9 equals 0. So if x plus 9 equals 0, that means that x is negative 9. And those are our two solutions. And again, if you graphed it, and we had y equals x to the second minus 9x, we can see that our solutions are 0, 0, and 9, 0, so that the x-axis, where it crosses the x-axis, is in fact our solution. Okay, solve the next one by factoring. Now the first step is to get it so that it's equal to 0. Well, it's not equal to 0 now, so we're going to have to move this side. So we're going to keep our 2a squared. 12a minus 3a is 9a, so we're going to add a 9a. And 1 minus 4 is negative 5. So, boom. Second step, make sure that it is in descending order. Squared, highest exponent, next highest exponent, last exponent. And then we're going to factor. Now, this one happens to be where we have a number that is not 1 here. So we're looking for factors of negative 10, because that's 2 times negative 5, that will combine to give us 9. So I like to start with 1 and 10, and that'll work if 1's negative. So that's my factors. So I now have 2a squared minus 1a plus 10a minus 5 equals 0. And we group it up. Group that factoring spirit up. Group it up. Woo! And we see that these both have an a, so we're going to factor out the a. So that leaves us with 2a minus 1. And we see that these both have a 5, because that's 2 times 5, and that's 5. So we're going to take out a 2. We're going to take out a 5. And that's going to leave us with 2a minus 1. Okay, and then when you look, you can see that they both have 2a minus 1s, and then you factor that out. So we have 2a minus 1, and we have a plus 5. And that's our polynomial factored. Then the next step is to set the factors equal to 0 by the zero factor or zero product property. So we're going to set each factor equal to 0. So if 2a minus 1 equals 0, so we've got 2a equals 1, and then a equals 1/2. Then our second part is a plus 5 equals 0. And so a equals a negative 5. And these are our solutions. And again, if we go back and type this into the calculator, now even if we type in the original equation, which I'm going to forget, 2x squared plus 12x minus 1, and that was supposed to equal 4a plus 3. We're looking for where these two intersect. One place they intersect, did I copy that right? Four plus 3a, sorry about that. So when we look at where they intersect, one place they intersect is at 0.5. The other place they intersect is at -5. So by doing it this way, we can make sure that when we set up our equation, when we got everything equal to 0, we don't have to make sure it's that we did that right. We know that we got the right answers to the original equation without actually typing it back in. Of course, we could always type in the equation that we had factored. And find where those are 0, and we found those. So where the zeros occur should be where they intersect. So you can see that that 0.5 and that -5 is where the graphs intersect. Okay? All right, solve by factoring. So the first thing we have to do here is we actually have to multiply and get everything equal to 0. So we've now got 4c squared minus 11c equals 3. And we're going to subtract 3 from both sides. So we have 4c squared minus 11c. Okay, so the first step's done. The second step, is it in descending order? Yes. Third step, factor it. So we're looking for factors of 4 times -3 is -12. That will give us -11. So I've got -12 and 1. Oh my. That was just ugly. Group it up. Factor things out. And now that we have it factored, we set our factors equal to 0 using the zero factor or zero product property. And so we have c minus 3 equals 0. So that means that c is 3. And we have 4c plus 1 equals 0. So we find out that c is -1/4 and c is 3. And again, 4c minus, okay, we can go to Desmos, type in x parentheses 4x minus 11 and 3. Get this one out of there. Where do they equal each other? 1/4 and 3. Or you could type in the one that we actually factored. And find that those cross the x-axis. Okay, so what I'd like for you to do is again pause the video and try these 4. So pause the video and try these 4. So hopefully you did pause and try to do these. So there's my work. Now notice here I took out a -2 because the first term's negative. Anytime your highest term is negative, your highest degree term is negative, you want to start by factoring out that negative because then it makes everything else easier to factor. Also notice that we had to have the terms add up to be -54 multiplied to equal -54. So that's 18 and -3. Okay, so now what I'd like for you to do, you can ignore this slide and just go ahead and work on the My Math Lab that says factoring quadratics by factoring.